Okay, so we're going to do 13.7. So in this question, we are given a linear cost function C as a function of Q equal to C times Q, and a linear inverse demand function P as a function of Q equal to A minus B times Q. Okay, so part A of the question asking you to write out the firm's total revenue function and its average and marginal revenue function. Okay, now so total revenue as a function of Q is just going to be equal to the price times the total quantity. Okay, so total revenue is the price that the firm is getting per unit multiplied by the total number of units that the firm is selling to the market. So in this case, the price is given by A minus B times Q and everything multiplied by Q. Okay, so if I expand the bracket, I get AQ minus BQ squared. So that is my total revenue function. Now, so in order to find the average revenue function, so average revenue as a function of Q, it's just going to be equal to the total revenue function divided by the total quantity. Okay. So I got AQ minus BQ squared, everything divided by Q. And so that's become AQ divided by Q minus BQ squared divided by Q. So that is A minus BQ. Alright. And my marginal revenue function is just going to be the differential of the total revenue function with respect to quantity. So if I differentiate the total revenue function over here with respect to Q, I get A minus 2BQ, and that is marginal revenue. Okay. Alright, so part B asking you to find the firm average and marginal cost function. Okay, so we are given the total cost function C equal to C times Q, and so the average cost function is going to be very straightforward. It's just going to be the total cost function divided by the total quantity. So C times Q divided by Q is going to give me C. So the average cost is constant and equal to C. And marginal cost is just going to be the differential of the total cost function with respect to quantity. And if I differentiate this with respect to Q, I get C as well, which is a constant. Okay, so part C is asking you to show that the firm generates zero revenue if it stops production or if it produces Q1 equal to B on A. Okay, so zero revenue. So I got total revenue function is IQ or I got I minus BQ times Q. Okay, so this is my total revenue, and so the firm would like us to show that the question would like us to show that the firm is going to get zero revenue. So if I set total revenue equal to 0, then if I'm solving this equation for the value of Q, then I get so this is going to be I minus B times Q equal to 0 or Q equal to 0. Okay. Now, so therefore, if I'm solving this equation, I get Q equal to A divided by B. Okay, or Q equal to 0. Okay, so again, this is a typo in the question. It should be A on B, it's not B on A. Okay, it should be A on B. So either not producing anything where Q equal to 0 or producing Q equal to A on B, that is going to give the firm a total revenue of 0. Okay, so part D asking you to show that the firm maximizes revenue by producing output Q equal to A on 2B. Okay, so again, the total revenue is A minus BQ times Q. Okay, and we would like to find the level of output that is maximizing the revenue, and so that it's just going to be the output that satisfies the first order condition. Okay, so if I differentiate the total revenue with respect to Q, this is just basically the marginal revenue. Okay, and as we found earlier, is equal to A minus 2B Q. Okay, and I would like to set this equal to 0 because I want to find the stationary point, which is either the minimum or the maximum point. So if I'm solving this equation, I get Q equal to A divided by 2B. Okay, so to confirm that this is the quantity that is going to be maximizing the total revenue, not minimizing it, then you just have to find the second order conditions where you differentiate the first derivative again with respect to Q. Okay, so the first derivative is A minus 2BQ, and if I differentiate this again with respect to Q, I get negative 2B. Okay, and given that A and B are positive, okay, then this thing is going to be smaller than 0. Okay, so given that the constant A and B are positive, okay, therefore negative 2B is smaller than 0. Now, if the second condition is smaller than 0, we know that the stationary point we found from the first order condition is going to be the maximum point. Okay, so therefore total revenue is going to be maximized at the point Q star equal to A divided by 2B, or QM, okay, which is what the question is telling you. Alright, so part A shows that the firm breaks even by stopping production or else by producing Q0 equal to A minus C's on B. Now, the firm breaks even is when the total profit is equal to 0, okay, which is basically meaning that the firm doesn't earn anything. So the first thing we have to do is to write out the profit function. Okay, so the profit function for the firm is just going to be the total revenue minus the total costs. Okay, so given that the total revenue is AQ minus BQ squared, okay, which is what we found earlier, and the total cost function is given to us equal to C times Q. So this is basically the profit function. Okay, so now the firm, so if I simplify this, I get Q outside the bracket, I get A minus BQ minus C, and everything multiplied by Q. Okay, so the firm will break even when the profit equal to 0. Okay, so I'll just have to solve this equation over here, A minus BQ minus C times Q equal to 0. Now, so this is going to be equivalent to either A minus BQ minus C equal to 0 or Q equal to 0. Okay, so therefore, solving this equation for Q, I get Q equal to A minus C, everything divided by B. Okay, that's right. Okay, or Q equal to 0. So as you can see, the firm is going to break even if it's producing either Q equal to A minus C on B or producing nothing. Okay, so stop producing or producing this much. Okay, so part F show that the firm maximizes profits by producing output Q star equal to A minus C on 2B. Okay, so again, I got the profit function is AQ minus BQ squared minus CQ. And now I want to find the level of output Q such that the profit is maximized. Okay, so therefore, in order to find the maximum point, again, I just have to find the first order condition. which is going to give me either a maximum or minimum, and use the second order condition to confirm that I have found a maximum point. So if I differentiate the profit function with respect to Q, then I get A minus 2BQ minus C, and I would like to make this equal to 0 in order to find the stationary point. So I'm solving this equation for Q. I get Q equal to A minus C, everything divided by 2B. Okay, now to confirm that what I have found over here is a maximum point, I just have to find a second derivative where I differentiate the first derivative again with respect to Q. Now, so if I differentiate this expression again with respect to Q, then I'll get negative 2B, okay, and that is smaller than 0 again, okay. So with this being smaller than 0, then I'll confirm that Q star is a maximum point. Okay, so therefore the profit is going to be maximized at the point Q star equal to A minus C, everything divided by 2B. Okay, and the last part is asking you to sketch the two diagrams, one showing the output Q star, QM, Q0, and Q1 on the total revenue and cost curve, and the other showing these output in relation to average and marginal revenue and average and marginal costs. Okay. Alright, so the first diagram is going to be about the total cost and the total revenue. So total revenue and the total cost, where the quantity over here is the output. Okay, so easiest way to draw is to start with something easy. Okay, so I know that the total cost function equal to C times Q. So we know that this is just a linear straight line with the slope of C. Okay, so it's going up and it's a straight line, so I'm just going to draw that first. Okay, and when Q equal to 0, cost equal to 0, so we know that it starts from the origin. Okay, so this is my total cost function. Okay, which is equal to C times Q. Now the total revenue is IQ minus BQ square. Okay, so now we've got square term over here, so we know that it's going to be a quadratic function. Alright, so we know that when Q equal to 0, total revenue is equal to 0. So that's the first point. Okay, so it's starting from here as well. Alright, now we also know that from before, the total revenue is going to be equal to 0. Okay, when Q equal to A on B or Q equal to 0. We found that earlier. Okay, so total revenue, so this is total cost, total revenue. So total revenue equal to 0 when Q equal to A on B or Q equal to 0. Okay, so I got 2 points. One is when Q equal to 0, which is here, and one is Q equal to A on B. So I just make up some random point A on B over here. Okay, so these 2 points is going to be on the total revenue curve, okay, when total revenue is equal to 0. And another point we found earlier is when the total revenue is maximum. Okay, so total revenue is maximized at the quantity QM equal to A on 2B. We found that as well. So total revenue is maximum at Q equal to A on 2B. Okay, at QM. Okay, so this is Q1. Alright, so A on 2B, now this is A on B. We know that A on 2B is going to be half of it, okay? Which is over here. because ion 2b is just basically ion B divided by 2, so the point is going to be half of the ion B. Okay, so that's the maximum point. So this is QM. Alright. Now at the point where QM is equal to A on 2B, then I want to find out what is the value of the total revenue. Okay, so the total revenue is going to be at the maximum value, and that value is A. So if I sub the value of Q back into the total revenue function, I got A times Q M, which is A on 2B, minus B times Q square, which is A square on 4B square. So simplify this, I get A square on 2B minus A square on 4B. And so that is going to be A square on 4B. Okay, so the value of the total revenue, I would say somewhere here. Okay, so this is A square on 4B. And so this is the maximum point on my total revenue curve. Okay, so knowing that it's going to go through this point, and it's a maximum over here, and it is basically a quadratic function, so it's going to have a parabolic sort of curve, and I should be able to draw it straight away like this. Okay, sorry. Okay, sorry, so that is just going to be like this. Okay, so this is my total revenue curve. Sorry, it's not very nice, but generally that's the shape of the total revenue. So it's concave going through these 2 points on the horizontal axis, and maximum at this point. Okay, so this is the QM, and this is the Q1. Alright, so okay, so the firms is asking you to show the Q star, which is, and Q0, which is the quantity that where the profit is equal to 0 and the profit is maximized. Now we know that the profit is just the difference between the total revenues and the total costs. Okay, so when the total revenue is equal to the total cost, which is the intersection over here, then the firm is going to be break even. Okay, so it doesn't make any profit. So this point over here is going to be the point at which the quantity is equal to Q0, which is equal to A minus C, everything divided by B. Okay, because that is the quantity at which total revenue is cutting the total cost. So total revenue at this point equal to total cost, and so therefore the profit is equal to 0. Okay, and the point where Q star, where the profit is maximized. Now the gap between the total revenue and the total cost is the profit. Okay, so for anything that is having total cost above the total revenue, so anything beyond this point to the right, then we have a negative profit because the total cost is higher than the total revenue. Okay, now anything to the left of this point where the total revenue is higher than total cost, we have a positive profit. Okay, and the distance between the total revenue and the total cost is going to be the profit. And as you can see, the distance is going to be maximized somewhere over here. Okay, so as you can see, this distance over here is the biggest gap. Okay, which is the biggest distance And so therefore something like this is going to be, so this is the profit max, okay, and so therefore at this quantity over here I would say this is Q star, okay, where the distance between the total revenue and the total cost is maximized, which basically means that the profit is maximized at that point. Alright. So now the second graph is going to show the average and the marginal revenue and the average and marginal costs. Okay, so I got average revenue, marginal revenue, average cost, marginal cost, okay, and this is the total quantity Q. And okay, so we have average revenue is equal to okay, A minus BQ, okay, and the marginal revenue is A minus 2BQ. Okay, so I'm going to draw these two lines on a diagram first. Now, so as you can see, these are very straightforward. They are just basically the linear functions of Q. So on a diagram, they are just going to be two straight lines. Okay, so for the average revenue, when Q equal to 0, average revenue equal to A. So I'm going to start from, so for example, say somewhere here. Okay, and okay, so when Q equal to 0, average revenue is equal to A, and when average revenue is equal to 0, then Q equal to A on B. Okay, so I got two vertical and horizontal intercept. So when Q equal to 0, average revenue is A, so that is the vertical intercept, and where Q equal to A on B, average revenue is going to be equal to 0, so that is the horizontal intercept. So just say I got A on B somewhere here. Okay, so if I connect these two points together, then I'll get a straight line, and this is my my average revenue line. Okay, now marginal revenue is A minus 2BQ. And so again, very straightforward. I want to find a horizontal and vertical intercept. Okay, so vertical intercept is where Q equal to 0, marginal revenue is equal to A. Okay, and horizontal intercept is where marginal revenue equal to 0, then Q is going to be equal to A on 2B. Alright, so starting from the same point, vertical intercept A, and horizontal intercept is where Q equal to A on 2B, which is half of the A on B. Okay, so A on 2B, which is here. Alright, so if I connect these two points together, I'll get the marginal revenue line, which is this. Okay, so now I'm going to do the average cost and marginal cost. We found earlier both of them are equal to C. Okay, so therefore it is just going to be a straight horizontal line over here. Okay, so this is the value C, so this is my marginal cost and this is my average cost as well. Alright, so on the diagram I would want to indicate the quantity Q star, which is the quantity at which the profit is maximized. Now, we know that the profit is going to be maximized okay, at the point where the marginal revenue is equal to marginal cost. Okay, because as you can see, the profit is just the total revenue minus the total cost. Okay. Alright, and in order to find a point that is maximizing the profit, if you remember, we differentiate the profit function with respect to Q, okay, and make that equal to 0, which is the first order condition, okay, so the profit max. Now, so if we differentiate this profit function with respect to Q, is basically the differential of the total revenue function with respect to Q minus the differential of the total cost function with respect to Q, and we make that equal to 0. Now, obviously, as you can see, the differential of total revenue with respect to Q, you get marginal revenue. And if you differentiate total cost function with respect to Q, you get marginal costs. And so therefore, at the profit maximizing point, the marginal revenue is going to be equal to marginal costs. Okay? So therefore, the intersection between marginal revenue and marginal cost, which is this point over here, is going to be the profit maximizing point. Okay? So therefore, the quantity at this point is going to be Q star, which is equal to A minus C on 2B. Now QM, which is maximizing the revenue, okay? Okay, so I got total revenue is, so if I want to find a point that is maximizing the total revenue, okay, so total revenue is max when I differentiate the total revenue with respect to quantity and I'll make that equal to 0, remember, okay? So now if I differentiate total revenue with respect to quantity, I will get marginal revenue. Okay, so when marginal revenue is equal to 0, then the total revenue is maximized, okay? So the quantity Q star, sorry, the quantity QM, which is the quantity at which the revenue is maximized, is going to be at the point where marginal revenue is equal to 0, which is this one over here. Okay, so this over here is the quantity QM, which is equal to A on 2B we found earlier. Okay, so at this quantity where marginal revenue is equal to 0, the total revenue is maximized, and that is the quantity QM. Okay, so quantity Q0, the profit is equal to 0. Okay, so I got profit, which is equal to total revenue minus total cost equal to 0. Now, so if I divide both sides of this equation by, so I got total revenue equal total cost. Okay, now, so if I take total revenue divided by Q, and if I divide both sides of this equation by Q, then I get total revenue on Q equal to total cost on Q. Now, so we know that total revenue divided by Q is going to give me the average revenue, okay? And total cost divided by total quantity is going to give me average cost. Okay, so at the point where average revenue is equal to average cost, then the profit is going to be equal to 0, and that is at the quantity Q0. Okay, so on a diagram, my average revenue is here, and my average cost is here. So the intersection between average cost and average revenue is going to be the point at which the profit is equal to 0. Okay, and this is corresponding to a quantity Q0. Okay, and the last one is Q1, where the revenue is equal to 0. Okay, so Q1 is where the total revenue is equal to 0. Okay, now so total revenue equal to 0 means so if I divided both sides of this equation by Q, okay, then I get average total revenue on Q equal to 0, and total revenue on Q is going to be just average revenue. Okay, so the point at which the average revenue is equal to 0, that is the point where the total revenues is equal to 0. Okay, so basically that's the point over here, where average revenue equal to 0 and quantity equal to A on B. So that is basically Q1 over here.